Okay, so here we've got an example here. Okay, I want to see the relationship between marginal product and total product, and the relationship between marginal product and average product. Okay, so here we're assuming this is a company, it's got one machine, one form of capital. We'll say capital is fixed and land is also fixed. Okay, the only thing that this company can increase or decrease is the number of workers. Okay, so let's say, for example, there's only one sewing machine in this company. All right. So we're going to we have to tabulate our marginal product and our average product. Do we all remember the formula for marginal product? Mm-hmm. Mm-hmm. Yes. Marginal product equals total product 2 minus total product 1 over number of workers, which is Q2, minus the odd number of workers, Q1. Okay. Yes. Marginal cost, same concept. Even marginal revenue, same concept. Okay, so let's say you've got one sewing machine. Okay, and maybe let's say you are producing t-shirts. Okay, one sewing machine. You've got, and let's say maybe a 5 by 5 room where you are doing this sewing. So your capital and your form of land is fixed. So you at first you do not start with any workers, so you're not producing anything. So there is no marginal product and there is no average product. Okay. You hire the first worker. Okay. First worker is able to produce 5 shirts. Okay. So we move from 0 shirts being produced to 5 shirts. So the marginal product, which is the additional product brought in by this first worker, is just going to say 5 minus 0, that is 5. 1 minus 0, that is 1. Let me put it like this. So your new total product is 5, your total product is 0. Your new quantity is 1, your old quantity of workers is 0. You get 5. So this worker that you've hired, this first worker, is bringing an additional 5 shirts being produced in the company. Okay, because marginal product, this is just the additional output each worker brings. Okay, the additional output which each worker brings. Then average product, think of it as the output per work. Okay, average product output per work. So it's just the total product, total output over the number of workers. Okay, so this 5 is the total product divided by 1, number 1 work. Okay, so 5 divided by 1, that is 5. Okay, so the output per worker is 5 sheets. And this first worker you have employed is like is brought in an additional output of 5 sheets, even though it's the only one because it's producing 5 sheets. So we just take it like that's also the addition from 0. Now you've moved to 5. Any questions before I move to the next part? Okay, you now hire a second worker. Remember, you have still got one machine. You bring in a second worker. So what is the addition? We want to find out what is the marginal product or what is the additional output this second worker brings. Okay, so your TP2 is 20, your TP1 is 5. Now the change in the number of workers is always by 1, so our denominator always be 1. In the exam, you need to show all those workings, but here I don't want to be drawing too much. I'll just use the shortcut method. All right. So to get your marginal product, you're going to say 20 minus 5. That is 15. Okay, so this second worker has brought an additional output of 15. Average product, yes, the total output divided by the number of workers, 20 divided by 2, that is 10. Any questions before I move further? Okay, from 2 workers, now you've brought in a third worker. Total output has increased to 40. So what's the additional output brought in by this worker? So you're going to say 40 minus 20, that is 20. All right. So this third worker has brought an additional output over 20 sheets. Okay, remember you've only got one machine. Okay, now you've got 3 workers on one machine. Okay, so there is like they are utilizing the machine well. Okay, but you have to remember now, the more people that will be using the machine now start being overused. Okay, it starts getting overused. Okay, the average product at this stage, how much is each worker producing? We do the total output, 40 divided by 3. What is 40 divided by 3? 40 divided by 3? 13.3. So basically here each worker is, it's like each worker can produce 13 sheets each. Okay, once we're done with this table, then I'll show you now. This is the relationship between marginal product and total product, marginal product and average product. But as we're solving, just see how total product is acting as marginal product is increasing. Also look at average product, see how it's also reacting as marginal product is increasing. We go to the fourth work. Okay, from 3 workers, you've employed now 4 workers. Remember, still one sewing machine. So you have got 4 people now working on one sewing machine. Okay, so the total product has jumped from 40 to 49. So the marginal product, you say 49 minus 40, that is 9. So this fourth worker has brought an additional output of 9 sheets. Okay, average product, total product 49 divided by 4. What is 49 divided by 4? 12.25. Okay. You hire now a fifth worker from 4 workers. You now got 5 workers. Total output increases from 49 to 47. Oh, decreases now actually from 49 to 47. With 7 minus 49, that is -2. Average product 47 divided by 5. Okay. So you've got here at this point, you've got 5 workers working on one sewing machine. Okay. Then now you bring in a sixth worker. Total output now reduces to 44. Marginal product 44. So this fifth worker, it's like they're not bringing any benefit or extra output to your business. Okay. The fifth worker is of no benefit to your business. Probably as the 4 workers are using the sewing machine, the fifth worker is just waiting there for his turn to use it. Maybe one worker uses it from 10 to 12, the other one uses from 13 to 14 or to 15, the other one 15 to 17. So maybe the fifth worker, the only time he has to use this sewing machine is maybe the next day. Now you bring in a sixth worker, total output reduces. Maybe now the machine has broken down because too many people are using it. 44 minus 47, -3. Average output, 44 divided by 6, 7.33. Okay. So colleagues, now look at the table here. We start with the relationship between marginal product and total product. Let's focus on the column for total product and marginal product. So remember, as I said earlier on, when marginal product is increasing, total product increases at an increasing rate. So what we mean at this increasing rate went from 0 to 5, increased by 5. Then from 5 to 20, we increased by 15. From 20 to 40, we've increased by we've increased by 20. This is the increasing at an increasing rate. Okay, the increments are just jumping. Okay. Now, when marginal product starts to reduce, this is where the law of diminishing marginal returns starts. Okay, the law of diminishing marginal returns will start where marginal product starts to reduce. Total product will increase at a decreasing rate. You see, from 40 to 49, the increment is just by 9. You see, earlier on our increments were by 15 and 20. Now the increment now has gone down to just by 9. So when we say total product is increasing at a decreasing rate, it means the increments are small. Okay? When total product is increasing at an increasing rate, you've got big increments. Now, if total product is increasing at a decreasing rate, the increments start to reduce. Okay. Then eventually, as marginal product continues to fall down, we see total product has started now dropping down, which brings us back to the law of diminishing marginal returns. As you keep on adding variable factors of production, in this case, workers, whilst other factors of production are fixed, in this case, the small room you have for sewing and the sewing machine, first your marginal product will start to reduce. Then after that, eventually your total product will reduce. Any questions? Before now we look at the relationship between marginal product and average product. Okay, so if we now look at marginal product and average product, we can see that as marginal product is rising, okay, as marginal product rises, average product is also rising. Okay, as we can see 5, 10, 20, 5, 15, 20. Marginal product is increasing. Also, average product is increasing 5, 10, 13.3. All right. But when marginal product starts to reduce, it means also average product is going to also reduce. Okay. I've seen when there was a drop from 20 to 9, even average product from 13 to 12.5. There's a drop from 9 to -2, average product also dropped to 9.4. When there was a drop from -2 to -3, average product also dropped at 7.33. Okay. So think of it like marginal product is like a magnet to average product. When it's increasing, average product increases also. When it reduces, then average product will also reduce. Is that okay, colleagues? Any questions? Good evening. Yes, there's a point where you don't need to hire more workers. At point three, when you reach point three, okay, although point four, I'll get back to you on which point to stop because point four, your output is 49. That's the highest output. So I would say between three or four. Yes, yes. But as you said, the last statement, as marginal product reduces, average product will also reduce. When marginal product goes up, average product goes up. Oh, and one more point. When marginal product equals average product, meaning they intersect, okay, the marginal product graph and the average product graph intersect, then average product is at its maximum. Okay. When marginal product equals average product is at its maximum. So remember that point. The graph, it will show where there is an intersection between these two. So you might find it now, since it's between, I would say between um, 3 and 4. So it might be at a point like 2.1, 2.3. Because in this table here, there's no point where the marginal product was equal to average product. So we can't see here. But when you graph, you'll be able to see where there's an intersection, you have a number there, but it will be a decimal number. Yes. No, 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 no. It does relate to economies of scale. Once we start bringing in marginal costs, average fixed costs, there will be a relation. There will, yes. So remember those, these might come in multiple choice. Okay. Remember the relationship between marginal product and total product, the relationship between marginal product and average product. Then we can now look at the relationship between marginal product and marginal cost. So these two have got an inverse relationship. Okay, when marginal product is increasing, let me make space like this. This green line will be the marginal product. Yes, marginal product usually its graph is something like this. And marginal cost, it's like the upside, it's upside down. And by marginal cost, it's like a Nike sign. The colleagues, what's the reason why the marginal cost curve is like a Nike sign? What is the main reason it slopes like that? It's because of the law of diminishing marginal returns. That's why the marginal cost. They usually ask that type of question. The reason why the marginal cost curve is like a Nike sign is due to the law of diminishing marginal returns. Now, here in this relationship here, what we can see is when marginal product is increasing, meaning each worker that you're bringing in is bringing more output. Okay, they're bringing more output, and more output it means more revenue. Okay, so they're bringing more revenue than what they are costing you. Okay, marginal product is increasing. Each worker you bring in, they're increasing output, and when they increase output, they're bringing in more revenue. So the revenue that each worker is bringing is exceeding the cost you're incurring to hire each worker. But the moment where each worker stops bringing value to your company, Okay, they're no longer bringing any additional output, or the output that they bring is starting to reduce. It means also your revenue will also start to reduce. And now that revenue and the cost is going to start catching up with that revenue. And then the more idle workers that you have who are bringing no additional output, they're going to cost the company more because they're bringing less revenue to the company. They're bringing less productivity, less revenue. So it means like you're just paying them for nothing. Any questions? So that's why these two have a inverse relationship. Any questions? So as marginal product increases, each worker is bringing more productivity into the business. That productivity translates to more revenue. So they're bringing in more money than they are costing you. But when your workers stop being efficient and they stop bringing uh, more output to the business, to be costing you more to keep them in the business because they're bringing less revenue than what they are costing you. So they're bringing in less revenue, so they're costing your business more. Yes. Any questions before we end here?